about you now, and I totally forgot about you. So, we are on section 2 about means, and I'm going to recap real quick. It'll be good for y'all too. The sampling distribution of two means, this is what is meant by that. It's x bar 1 minus x bar 2 for every possible sample of size n and how often they occur. That's just a regular definition of sampling distribution. Your next question was, what are the shape, center, and spread of the sampling distribution of x bar 1 minus x bar 2? And are there any conditions that need to be met? Yes, just like always, the shape is normal if both of the distributions are normal, or if both of them have a sample size greater than or equal to 30. And if they don't, then you have to graph them and look for skewness or outliers, and that's each one individually. Now you can make a combination of this. Like population 1 could be normal, and population 2 we don't know. So then for population 2, you would have to look for n is greater than or equal to 30 or graph it. Does that make sense? Like each one has to meet one of the qualifications. Each sample or each population has to meet one of the qualifications. They don't both have to be from normal distributions. You could have one from a normal distribution and one have a sample size greater than or equal to 30.
So if you had one sample size that was like 35 and one that was like 25.
Then you would need to be graphing the 25, gotcha, unless it said it was normal. All right, the center of the distribution of x bar 1 minus x bar 2 is mu 1 minus mu 2. And just for review, that means that x bar 1 minus x bar 2 is an unbiased estimator of mu 1 minus mu 2. Okay? Oh, man. Some weird. So, and then we looked at the standard deviation. This formula is on your formula sheet, so no worries. This is the same thing over and over again. The standard error. Okay, when we have to take the sample standard deviation and plug it in, that is called the standard error. Now, finding the t-statistic, I will say this again. Finding the t-statistic, here is our lovely formula. And you are welcome to use this lovely formula, but this formula is not on the formula sheet. The formula sheet says statistic minus parameter divided by standard deviation of statistic. So if you know, you would probably get the statistic, x1 bar minus x2 bar. But you might forget the parameter that you were trying to estimate, mu 1 minus mu 2, and you might mess up here somewhere. So I would suggest that you let your calculator do it for you, Kelsey. You're not here, but I would suggest that you let the calculator do it for you, especially to find the degrees of freedom. We don't have the ability with what we understand in AP Stats to calculate the degrees of freedom for this on our own. So we can either use the calculator, or if you're brave and you want to do it all by hand, then you can use the smallest sample and do n minus 1 for the smallest sample, and that would be the conservative approach. So I would probably use calculator. All right, the conditions when you are doing a confidence interval or a test about mu 1 minus mu 2. Okay, so we've got two different sample means, and we're going to do some kind of inference about the population means. Again, random, both have to be from random samples, or both have to be from random assignment to treatments if you're doing an experiment. If you're doing an experiment, you don't have to check the 10% rule. But if you're doing random sampling without replacement, then you have to check the independence rule for both of them. The sample is less than 10% of the population for the first one and the second one. And then final, you check normal for both of them. There is the formula for the confidence interval. Is this formula on the formula sheet? No, this formula is not on the formula sheet, but the generic formula is statistic plus or minus the critical value times the standard deviation. Okay. How fun. Confidence interval is going to be at the very beginning of section 3. Inferential, whatever, on the formula sheet. Oh, it's not on your note sheet. Okay, so now on your note sheet, well, we're not there yet. Significance test. Okay. 2 means could just be difference by chance, or they could have a true difference. And that's what we do in a hypothesis test. We'll determine the ho, that there's no difference, or the ha, that there is a difference. And that ha can be 3 ways: greater than 0, less than 0, or not equal to 0. Something else I want to show y'all is that on the AP exam, you may see it written like this for the ha. That the mean of the first group is greater than the mean of the second group. That's the same as this. Okay, if we were to bring mu2 over and subtract it and get 0. Okay, and so you may see mu1 is less than mu2. And a lot of times, that's the way it'll be worded in the question. Say like, is the mean for the group that took AP Stats higher than the mean for the group that took AP Calculus? Okay, the mean amount of stress. Okay? All right, we're ready for our example. Leaking helium. Everybody get to that one. Leaking helium. All right, after buying many helium balloons only to see them deflate within a couple of days, Aaron and Jenna decided to test if helium-filled balloons deflate faster than air-filled balloons. I guess that would be like with your breath. Yeah, or a pump. To find out, they bought 60 balloons of the same type and randomly divided them into 2 piles of 30, filling the balloons in the first pile with helium and the balloons in the second pile with air. Pause. What were they doing? What were they exhibiting by buying 60 balloons of the same type? What was that a form of? Control. Okay? Because otherwise the quality of balloon might have been confounded with its ability to hold air. Not with its ability to hold air, but whether it got air or helium. All right, so filling the balloons in the first pile with helium and the balloons in the second pile with air. Then they measured the circumference of each balloon immediately after being filled and again 3 days later. The average decrease in circumference of the helium-filled balloons was 26.5 centimeters, with a standard deviation of 1.2 centimeters. The average decrease of the air-filled balloons was 2.1 centimeters. That's a huge difference. With a standard deviation of 2.79. Let me make sure that's not a typo.
Would you even have to test that?
Yeah, that is the correct.
13 times more.
Guess what our p-value is going to be. I'm just looking ahead. Can you guess what the p-value will be? Approximately 0. Okay, but that's what happened in this example, so let's do it. Part A. Why is it important that they used the same type of balloons? What is this called in experiments? Control, and it helps what? Reduce confounding. Does it totally eliminate confounding? No, but it helps reduce it. What would be confounded? If they didn't buy the same balloons, what would be confounded?
The material.
Quality of balloon with, what is it confounded with? What can you not tell it apart from? Air or helium. Okay? With the type of filling. Because you wouldn't know if it was the type of balloon that was making it decrease in circumference or if it was the filling that was making it decrease in circumference. All right. Do these data provide convincing evidence that helium-filled balloons deflate faster than air-filled balloons? When it says, do these data provide convincing evidence, what should we do?
test, dude.
We should do a test. Okay, so how do we start a test? State. Kelsey, I'm going to pause you for now because this is going to take a while. All right, so our hypotheses are that the mean decrease in circumference of helium-filled balloons and the mean decrease in circumference of air-filled balloons is 0, meaning there's no difference. Or our the mean decrease in circumference of helium-filled balloons is greater than the mean decrease in circumference of air-filled balloons. Again, if you wanted to write them like this, you could. If you wanted to write it like this, you could. They're the same. The decrease is the same. Or the decrease of helium is greater than the decrease of air-filled. I tend to fall here. Okay, this is where I tend to go. But you learned it this way with proportions. So if you want to stick with that way, that works too.
Our answers will be written that way. Like if you had a question
Could be written either
like
way.
multiple choice.
It could be written either way. What am I doing? Okay, so our plan, conditions for a 2-sample t-test. We know we have 2 samples because we had 2 different treatments. This is an experiment. We don't have to we do random because they're randomly assigned to air or helium, so they were randomly assigned treatments. We don't have to do independence because this is an experiment. We weren't randomly selecting from a population without replacement. You never do independence on experiments. And then normal, both sample sizes were at least 30. They were exactly 30. So now we're going to do the do step. This is where I would want you to use your calculator. So everybody take out your calculator. Kelsey, find a calculator. Go to stat test. Which one are you picking? 2 sample t-test. What number is that? 4. Do we have the data or do we just have stats? We have stats. What would we do if we had the data? Where would we put it? L1 and L2. You are so smart. Now, when you click on stats, you have an X bar 1. Okay? That's our helium. We did helium was our first one. So what was that? 26.5. And our SX1, 1.92, that's the sample standard deviation. And what was the N1? The sample size, 30. Now do the same thing for air-filled. That's going to be 2.1, 2.79, and 30. Pick the direction that your hypothesis has stated. Okay, we were doing greater than, so pick the last one, greater than. Pooled, choose no.
Oh my gosh.
Always choose no on pooled.
Keep out of it.
And hit calculate.
1.9, negative 40th, 39 zeros. I'm not writing that one out.
Okay, so what did you get for your T?
Right.
T equals 39.46. P value is
Right.
0.0000039 zeros, and then a 1983. Okay, so it's 0, which we knew because there was such a big difference in their decrease in diameter. What else do I need to record for a t-test? Degrees of freedom. And so we use our calculator to get that, and it is 51.4. So finally we conclude with a p-value of approximately 0 less than any reasonable alpha, but we'll use alpha equals 0.05 because it didn't tell us what to use. We what?
Reject.
We reject the hoe. What do we do after we reject the hoe?
We have significant evidence.
We have significant would be fine, but we're going to say convincing. We have convincing evidence that what?
The difference in the decrease of circumference
Is greater for
Here.
Wait, are we doing the difference?
That might be the word in the end.
This one would probably would have been easier to do like just the means.
So you could have said we have convincing evidence that the mean decrease in circumference of helium-filled balloons is greater than the mean decrease in circumference of air-filled balloons. You could also write that we have convincing evidence that helium-filled balloons deflate faster than air-filled balloons, because that is what was asked. It says, do these data provide convincing evidence that helium-filled balloons deflate faster than air-filled balloons? So you can include it that way with what it asked, or you can include it with your ha. We have convincing evidence that the mean decrease in circumference for helium-filled balloons is greater than the mean. It's a lot more writing, but decrease in circumference for air-filled balloons. Again, if you had all your wits about you, and you remembered this, you could just go back up to the part where it says, do these data provide convincing evidence that helium-filled balloons deflate faster than air-filled balloons? And you could say, we have convincing evidence that helium-filled balloons deflate faster than air-filled balloons. Okay? Or, we do not have convincing evidence that if we had not rejected the hoe. All right. Okay? Now, interpreting the p-value. Do y'all have that on yours? Okay, this is good review. Interpreting the p-value. What does our p-value of 0 mean? Okay, there is a significant difference, but how do we interpret a p-value? Assuming that what? The hoe is true. Assuming the null is true. And what is the hoe? Assuming there is no difference in decrease of circumference for helium and air-filled balloons. Oh, I'm so tired of writing. So, assuming that there is no difference for the decrease in circumference for helium and air-filled balloons, for the mean, there is no difference in the mean decrease. We need to say something about the mean because that's what we're testing, is the mean. Assuming there is no difference in mean decrease of circumference for helium and air-filled balloons, what? We have a probability of what? Of 0. So what has a probability of 0? getting a difference this great or greater. So getting a difference of, what was the difference? 24.4.
It was like at least as extreme.
Yes, as extreme or at least as extreme.